Today, the topic is history and motivation for database systems. Let's go over the brief history of database system. In early 1960s, Mr. Charles Bachman at GE kind of introduced this first database management system. Later, it got recognized by Kodak, which is a Committee on Data Systems and Languages. Late 1960s, IBM introduced information management system which follow hierarchical model and it got implemented in Sabre, which is an automated ticket booking system. In 1970s, Mr. Edgar Cord introduced this relational data model. In 1980s, IBM introduced this standard query language and it got recognized by international standards for organization. In mid 1980s to 1990s, IBM and few other organizations also started to develop the strong and powerful system based on this relational data model. And this is the predominant model used till nowadays in IT industry. What could be the reason for this database management system? What problem it actually trying to solve? In the earlier days, we kind of use this flat file. So all these flat files are difficult to handle, and if you do a large chunk of data if you have, and it's pretty difficult for us to handle all this information, and if you want to search something and it's kind of a difficult. So there comes the motivation. The problem here is if we have a large volume of data, for example, if a global supermarket is there, you might need to provide a solution for the problem, like you want to document every inventory, whatever the purchase made in a particular branch, whatever that selling happened in the particular branch. So you have to accumulate for each and every day for each and every branch of the supermarket across the globe, which is a tedious task because we use this flat file. So flat file for the historical data, if you want to go and search for something, tremendous effort is kind of required for it. If this problem is being given, and how do we go ahead and find and pull the data from the flat file? So how many flat files are required? We might require a hell lot of flat files for the historic data as well, and present day data as well, and for the futuristic data as well. If we have n number of flat files, then there comes the consumption of more memory for us in the computer. And what could be the complexity even if we have flat files for the historic data and the present day data? If you want to do an operation on all this flat file and the data, it's little difficult. Why? If you want to find some criteria like what and all purchase happened in the past 10 years, for example, how much hard drinks sold in the particular branch, how do you able to get that? So we have to go over and over of all these flat files, and we have to come up with a value to get that, which is a tremendous effort, and also it might require more amount of user time and manual intervention. Secondly, maybe if you want to override some data in the past file, so you have to go ahead and do that. It's also a kind of difficult process. Next one is if you want to give a concurrent access to the people in different location for the same flat file, that also difficult. So one person has to wait until the first person completed all the manipulation of the data, and then subsequently the second person can pitch in and do whatever the editing or manipulation he want on the flat file. So these are the complexities. These gives that motivation for us to develop database management system. So before going ahead with database management system and what is database and what is the use of this database management system, we go over with a different model. What are this? What are the drawbacks of this? How the structure will be? We'll see in the subsequent slide. So we know hierarchical is there, network model is there, relational model is there. First, hierarchical model. Hierarchical model is a parent-child type concept. If you want to find a particular record, it always end up with only one child. So that's what the problem for this hierarchical model is. A lot of limitations are there, and since it's a parent-child concept, it always share one parent with multiple child. So it will leads to one to many concepts. It will not allow many to many relationship. Second one, network model. Here the relationship between each record will be held with the help of links or pointers. So here the data for one parent can have multiple child and vice versa. Single child can also have multiple parents. So that is the advantage of this network model. But still, if you want to narrow down and find a particular data, somewhat easy as compared to hierarchical model since it have multiple access bar, but it's not that easy as compared to relational model. In relational model, every data records that relationship will be maintained with the help of keys. If we want to identify any record of a particular person, we can find easily with the help of unique key. This you can relate in the real time. So you have one key for your main door in your house, for lockers one key. So you can have a unique key, so that key will be able to unlock the particular door. So the same concept you can apply here for relational model. And let's go and see that what is the structure of each and every model. Hierarchical in the name itself defines. Hierarchical is upside root model. You can compare in the real time. A company is having a CEO followed by vice presidents. Each vice president will have lot of directors, and each of these directors will have managers followed by leads followed by the final employee. So that's how that parent and child relationship. So it will not be like one manager can have multiple directors. It always be only one to one mapping, whereas one director can have a number of managers. So that's what that hierarchical model is. Next one is network model. Here many to many link, that is a single person can be a father, can be a son, can be a grandson, can be an uncle. So these all relation can be for only one person. So one person can have multiple relationships. So that's what the network model is. Since it allows many to many relationship, here the drawback is if you have huge volume of data, the complexity grows based on the amount of data. So it's difficult for us to maintain the relationship between the multiple components if you have to incorporate each and every new data that we need to accumulate. So that's why it's pretty slow as well, and it's complex. And finally, relational data model. In this relational model, we will have everything as an entity. The entity can be your role, can be a place, can be a thing, can be a person. Each and every characteristics of a person can be portrayed as an entity. For example, if a person A is there, the person can be an individual, and he or she can carry name, gender, place of birth, date of birth, and he or she, that particular individual, will be a member of a family. So the family and family related details can be stored in a separate entity. Likewise, what is the relationship he is having with the family, so that will be documented in a separate entity. What are different types of relationship he can have, that can be documented in a different entity. And what are the roles he will be playing, like he can play a role of a father, he can play a role of a child, he can play a role of grandson. So all these things are possible. So it's easy for us. You can point out one person name like ABC, he's a son of XYZ. You can easily narrow down and pick up that respective relation. What's the relation ABC is having with BMW? So this is how it's very easy, and everything will be segregated. All this entity and finding each and every data from this relational model is pretty easy, and it's structured. You have a logical form where we have meaningful rows and columns for each and every attribute we collect for the particular individual. And finally, database and database management system. So database is a place where we collect all this data. If you take one pond, a pond is a place where you collect all the water, or maybe a dam is a place where you collect the water. So likewise, database is a collection or the accumulation of all the data. So that's what the database is. And what it will do, it describes the activities between one or more entities. That is, if person A is there, person B is there, what's the relationship he is having with A, is having with B, B is having with A. So this is what that database talk about. Okay, this is database. What is the database management system? What's the need for that? Once we have large amount of data and that all the data will be stored in the database, how do you go ahead and utilize that data? how do you go and maintain the data? That's where this database management system comes into picture. Here, it will help us to maintain the data, utilize the data. For example, a person is working in a company and he is having some 5 years of experience. So in his profile, he will be having the information about what and all expertise, technical expertise he is having, and what and all different projects he worked on. So that is what the collection of historic data. And he'll be utilizing that for a subsequent job he want in a different company. So likewise, database management system also, it will have a collection of historic data, and with that data we will be utilizing that for some present purpose or some futuristic purpose or for enhancements. So this is what database management system and database. So hope everyone able to catch up with the idea of what is the database and what is the motivation behind this database management system, and some brief history of what is the database management system, when and where it got invented, and what is the present model being used across the industry. If any questions anyone has, please send out a mail to curselearning at gmail.com. You can also drop a comment in this video and then we will get back with the answers for the respective questions. Happy learning. Thanks for your time.